Okay, good evening, ladies and gentlemen, and welcome to this day two of Lean Six Sigma Black Belt Hackathon. And is my voice loud and clear? And are you guys ready? Just give me yes in the chat box so that we can start our session for the day. Just give me yes in the chat box, and let's begin our journey. Voice is clear, loud and clear. Super ready? Fantastic, fantastic, amazing. चलो शुरुआत करते हैं. So just type in the chat box randomly what we have covered yesterday. Okay. So let's start with the recap. And I hope the people, you know 80-20 principle, right? 80-20 is Pareto principle. We all know that. There is a principle called 86-14 as well. Okay. What is that? 86-14 principle. Okay, so I'm just typing in the chat box. Okay, 86-14. What is 86-14? 86-14 is nothing but whatever we learn, study, understand, comprehend. Okay, 86% of it we forget on the same day. 86% we forget on the same day. Okay, so only 14% is carried forward to the next day. So what is the way out of it is the revision. Okay, that's why let's start with the revision. I always start the next day from the revision. Okay, yeah, type in the chat box. Yeah, it can be random. It can be random. Absolutely, yes. CLT, very good. CLT, Pareto chart, MSA. What else? What else? Type in the chat box. Type in the chat box. You can randomly type the topics we have covered yesterday, and then we'll start the topics of the day today. Yes, GRR, AAA, fantastic. So they are the topics of the MSA, measurement system analysis. So if you have the continuous data, we go for GRR. If you have discrete data, we go for AAA, attribute agreement analysis. Okay. Then SNC, stability, normality, and capability. That's what we have seen. Actually, it is done in the green belt itself, but then we just recollected that, and then we check the 6-pack analysis where SNC is done in one shot, right? That is called 6-pack analysis. Just a second. Yes, what else? Type in the chat box. सुपर. और क्या क्या देखा हम लोगों ने? Histogram, okay. Then we have seen how to generate the data from Minitab, how to generate the data in Excel sheet. Repeatability, reproducibility, how to create the worksheet for gauge RNR. Okay. Then how to analyze gauge RNR, how to analyze AAA. Right. So GRR value, and then the fleece kappa value, we have seen that. Correct? Very good, very good. Super. Yes, transformation. Then we have seen the if the data is non-normal, what happens? Right? So we have done the transformation. Before that, see, transformation is just like an operation. I will not recommend transformation in the beginning of it. It's like operation last resort, what doctor suggests, right? So initially they try to cure it with some, with some what you can say, our household remedies, then the medication, and then the operation. So these are the levels of remedies, right? Similarly, the transformation is the last resort. It's kind of operation of this. Okay. So before that, we try to eliminate the outliers of the data, try to investigate what is special cause variation. Okay. And then again, increase the sample size of it. So these are the remedies we have to do before we go for the transformation, correct? Then we have learned about Box-Cox transformation, which we have seen that. So we check the lambda value. According to lambda value, we check the table. And from the table, we respectively convert that values accordingly, respectively, okay? And then we do the capability analysis. So yesterday we have covered that. So today we are going to cover something very interesting. We are going to cover the hypothesis testing, which is, I would say, advanced hypothesis, because The basic hypothesis we have already covered in the green belt level. So today we are going to cover the advanced hypothesis testing. Okay. So here, see, I'm not covering whatever is common in green belt and black belt. Okay. Because whatever has been covered in the green belt level, I'm not covering it once again. Okay. So whatever is exclusively only used in black belt curriculum, that part only I'm covering in the black belt hackathon right now. So hypothesis, I'll just cover quick basics of the hypothesis. Now, in which phase hypothesis testing comes, type in the chat box. In the DMAC framework, in which phase hypothesis testing comes, type in the chat box, everybody. Majorly hypothesis testing comes in which phase? All the green belt certified people, type in the chat box. Okay, improve, what else? Analyze. Yes, type. Whatever right, wrong answer doesn't matter. You have to type out of 5 phases. Which phase do we use hypothesis testing? Everybody, type in the chat box. Measure phase, analyze phase. Only define and control is remaining now. Okay, improve ho gaya, analyze ho gaya, measure ho gaya. Only define and control is remaining. The first one and the last one. Okay, so the right answer is we use hypothesis testing predominantly. Okay, predominantly in the analyze phase. Make a note of this, guys. Of course, we use it. We use it once in the measure phase. We use it once in the measure phase. Okay, but predominantly we use it in the analyze phase. So what is the analysis phase phases roadmap? First, we go for fishbone analysis, correct? Which is cause and effect, fishbone, right? So we all know that man, machine, method, mother nature, etc. Right? So we get the primary causes. In the fishbone, we get primary causes. Then we do root cause analysis, RCA, where we get root causes. So in the fishbone, we get primary causes. In the root cause analysis, we get root causes. After root causes, see, in the fishbone and root cause analysis, we are not using data here. Understand this? Do we use data in fishbone? Type yes or no in the chat box. Everybody. When we do man, machine, method, mother nature, do we use data? No, right? We don't use data. While doing RCA, root cause analysis, or YY analysis, do we use data? Do we use data? No. In YY analysis also, we don't use data, right? We just answer the question why. Correct? So there is no data usage unless and until we go for validation of the root causes. So the next part after root causes, once we get the root causes, then we do validation of the root causes. And validation is done via hypothesis testing, regression correlation, design of experiments, etc. Type in the chat box, everybody. Are you clear with this? So right now, so we are here in the analyze phase where we are validating the root causes with the help of data. Hypothesis meaning our assumption. In fishbone and root cause analysis, it is our assumption, it is our hypothesis, which we have to prove with the data. And that is called hypothesis testing. Are you clear with this? Just type yes in the chat box. So this is the path, this is the flow of the analyze phase. First we do fishbone, then we go for root cause analysis, then we go for validation. Are you clear? Just give me yes in the chat box. Everybody. Clear hai? Very good. Now there are two questions. There are two questions before I proceed further. Okay. In green belt curriculum, what are two hypothesis testing we have done in green belt curriculum? Type in the chat box. The people who have been through the green belt, what are the two hypothesis testing we have done in the green belt curriculum? Type in the chat box. I'll wait for your right answer. What are the two different hypothesis testing we used in the green belt curriculum? HO and HA are the basic terminology of hypothesis. In the green belt, I'm still waiting for the right answer. No, not ANOVA, not non-parametric. Yes, parametric we have done. Parametric meaning wherever we have the normal distribution, the data is stable, normal, that is called parametric testing. Non-parametric meaning where the data is non-normal. No, not regression, not alternative. Okay, so let me give you the answer. Manoj ji has hit the right answer. So in the green belt level, we learned one sample and two sample t-test. How many of you remember this? Just type yes in the chat box. One sample and the two sample t-tests are covered in the green belt level itself. ANOVA, non-parametric, etc. we are going to cover in the black belt curriculum. Non-parametric भी black belt में नहीं है actually. वो हम लोग master black belt में cover करते हैं non-parametric testing. But if you are interested, you can check the details in the master class archive. I've covered non-parametric testing in the master class archive. You can check out that. Okay. So two sample t-tests. So right now, let me just, let me ask you another question. Okay. So first question was, what are the two, hypothesis testing we have learned, which is one sample t-test and two sample t-test. Let me ask you, there is one hypothesis testing we used in the measure phase as well. Who can give me the right answer? Measure phase में भी हम लोगों ने एक hypothesis testing use किया है. We have used one hypothesis testing in measure phase. Type in chat box. What is that? Kappa, close, but not what I'm expecting. What else? What else? एक hypothesis testing हम लोगों ने measure phase में use किया है. What is that? Come on, guys, green belt certified people. Think about it. Yesterday also we did that. I'm giving you a very super clue here. Yesterday also we did that. Scratch your head. Type in the chat box. Yes. Dr. Gupta has hit the exactly bullseye, which is normality. Anderson-Darling normality test, the p-value, which is less than 0.05, it is non-normal data. If it is greater than 0.05, it is normal data. That is also a hypothesis testing. How many of you got a bulb on moment? Just type BO in the chat box. Normality testing also is hypothesis testing, guys. Type BO in the chat box if you came to know just now. Super. Everybody. चलो तो आगे बढ़ते हैं. हाइपोथेसिस टेस्टिंग का बेसिक्स कवर करते हैं. देन we will go directly to the Minitab software and we'll touch upon the advanced hypothesis testing today. Okay. So we are going to learn some 4 to 5 advanced hypothesis testing, like ANOVA, like chi-square test, like F ratio test, etc. Okay. So where are these tests used? Everything I will cover today. So first, let me cover the basic fundamental of hypothesis quickly in 5 minutes, which will be a recap of the green belt. Okay. Let me remove this and let me quickly touch upon hypothesis testing. What is hypothesis? Hypothesis is nothing but assumption. Hypothesis is nothing but assumption, the statement of assumption, right? So we have two hypotheses. One is called null hypothesis, which is denoted by HO, which is statement of equality. And the second hypothesis is alternate hypothesis, which is denoted by HA, which is also called as statement of difference. Okay. So one statement says they both are equal. Okay, let's say average of one vendor. Let's say vendor A. So average of vendor A delivery time and average of vendor B delivery time. If I collect the data of delivery times and take the average, null hypothesis will say that both are equal. So this is called null hypothesis. And then alternate hypothesis, which is HA, will call it as it is statement of difference, that it will say that both are different, statistically significantly different. There is a statistically significant difference between both the averages. So both are equal and opposite statement. Then we collect the data and we put the data in the software called Minitab. So this is called as two sample t-test, because we are comparing two sample with each other. Everybody? Okay. So what I'll do is, first we'll do a Minitab exercise on two sample t-test, which is a part of a green belt itself. Okay. So let me just go back to two sample t-test. Just give me a second. All right, here we go. So can you just open this file called two sample t-test? Once you open the file, let me know in the chat box that file opened. Yes, once you opened it, let me know file open. Super. So let's try to understand this. The first column is male CCO and the second column is female CCO. What is CCO? CCO stands for call center officers. Call center officers. Okay. So in one of the call center, these people wanted to study the difference between the male CCO's performance and the female CCO's performance average. And they wanted to check, is gender playing some role here? According to the gender, is it creating some kind of performance differences? In the call center, it is expected to reduce, to close the call successfully within the least amount of time. That is what so that they can cater to maximum amount of clients and customers and satisfy their queries. Okay. So they have collected this data, male CCOs and female CCOs. Okay. So we have to do the two sample t-test because there are two samples here. How do we do that? Go to stat, basic statistics, two sample t-test. Everybody follow this path. Stat, basic statistics, two sample t-test. So this is a green belt stuff. I'm just repeating this. It is a green belt stuff. Stat, basic statistics, two sample t-test. Once you click on this, so here the drop down says both samples are in one column. So if you click on the drop down, it says both samples are in one column, each sample in its own column, and summarize data. So right now both these samples have each sample in its own column. So we'll select the central one. Okay, each sample in its own column. Just select this. Now you have sample 1 and sample 2. Okay, so just select male CCO in sample 1, female CCOs in sample 2. That's it. Everybody with me? Just give me a in the chat box. Thanks for the confirmation, everybody. Just give me the confirmation if you are with me or you're just lagging behind. So I'll just wait, explain it once again. Okay, you have to go to, I'll just quickly repeat, go to stat basic statistics to sample t-test. Stat basic statistics to sample t-test. Select the central one, which is each sample in its own column. Sample 1, select male CCOs. Sample 2, select female CCOs and say OK. Now, tell me, what is our famous rhyming of the hypothesis testing? What is our famous rhyming? Type in the chat box. Everybody, type in the chat box. What is our famous rhyme we use in hypothesis? Yes, absolutely right. Type everybody. If I believe everybody knows this, right? Because you are going to become black belt certified. So you must remember this. Simple Pilo Nalgo. So here we go. So right now, understand this. The first thing is that the male CCO, the mean is 11.63. So I will write X bar M or XM bar, which is the male average, is 11.63. Now just look at here. Okay, the female average XF bar is equal to 12.80. So is there any difference, guys, mathematically? Yes or no? Everybody type yes or no in the chat box. Is there any mathematical difference between these two? 11.63 and 12.80. Is there a mathematical difference? Yes? Yes, no? Yes. Correct, everybody? Yes, there is a mathematical difference. So why are we doing this hypothesis testing? See, with this small sample, there is a mathematical difference. But is this mathematical difference will be significant for the long term? That is what we are checking here. So if I draw, let's say, understand, this is the male CCO at 11 point, let's say 6. And female CCO is around here, let's say, for example, which is 12.8. Imagine these are two distributions I have plotted. Now so the overlapping area, look at this, guys. This is very, very important. This overlapping area, okay, if this area, now listen to me very, very carefully. If this area is 0. Okay, or I would say 5%, let's say 5% or less. Actually, this area is nothing but your p value. So if this p value, which is this overlapping area of this two distribution, if it is less than 5%, that is indication that there is a statistically significant difference between these two averages. This is X bar M and this is X bar F. If this p value is less than 5%, which is nothing but 0.05, we can say that the distance is statistically significant. Imagine this is not 12.80. Just understand this. This is not 12.80. This is 11.80. Imagine that scenario. Imagine for a second, the female average is 11.80. Still there is a difference, but that difference is not very high. So in that case, the distribution will look like this, guys. Understand this. So this is 11.6 and this is, let's say, 11.8. Okay. And this, the overlapping area is this p value. Now in this case, obviously the p value is greater than 5%. Whenever the p value is greater than 5%, that means we can say they are very close, they are very much overlapping, and not much significant difference between these two. How many of you got it? Just type yes in the chat box. How many of you got it with this example? Just give me yes in the chat box. किसको अभी bulb on moment हुआ है right now? This p value and hypothesis testing and whatnot. Have you understood this graphically? It is a graphical explanation of p value. How do we know p value here? Very good. I will explain you the calculation of p value as well. Okay, manually calculate bhi karenge. Okay. So right now, so this is the graphical part. Okay. I will take care of the statistical part as well. So come here. So male average is 11.63. Female average is 12.80. Okay. And you can see here p value is 0.044. So our rhyming, we are, p low, null go. That means if the p value is lower than 0.05, we reject null hypothesis. So in this case, the p value is lower than 0.05. So we reject the null hypothesis, which is the statement of equality, which says x bar m is equal to x bar f. That means the male average and female average is same. That is what the null hypothesis says, but we have to reject it because the p value is lower than 0.05. So we have to accept the alternate hypothesis, which says there is a statistical significant difference between these two averages. And we can clearly see that the female average of closing the call is much higher than the male average of closing the call. Are you clear with this? Just type yes in the chat box. So we just check the p value and accordingly we basically decide. Clear hai? Just give me yes in the chat box. So what we do, we collect the data, we feed the data in the software. Software will give us the p value. Accordingly, we have to take the decision whether to accept or reject the null hypothesis. Just give me yes in the chat box if you have understood this. And now I'll give you a practical case and we'll calculate the p value manually. Do you want to learn that? Just give me yes in the chat box. Are you interested? If you're interested, let me know. Haji, interested hai. Chalo. Okay. Very good. Super. So let me take you to the whiteboard once again. Let me take you to the whiteboard once again. Okay. And so p value is called as probability value. Okay. So let me give you an example of sample z test. Okay. P value is greater than 0.05, then accept null hypothesis. Exactly right. Absolutely right, Dr. Gupta. Absolutely right. Okay. Let me explain you one sample z test. Okay. Now, what is the difference between a z and a t? These are two distributions. Okay. What is z distribution? Z distribution is nothing but our simple normal distribution. What is t distribution? Now, if you remember yesterday in our first session, first topic which we covered, CLT, which is central limit theorem. As we increase the sample size, the distribution becomes normally distributed, right? So what is the minimum number of sample size which are required to get normal distribution? Type in chat box. What is the minimum number of data points to get the normal distribution? Minimum, bare minimum. Ha, absolutely right. So make a note of this. Bare minimum 30 data points you should have according to statistics. Okay, minimum 30 data points you should have, you should collect, so that your distribution will take the normal distribution shape. Now, what if you don't have the 30 data points? Okay, still you can go ahead with a distribution which is a little flatter distribution like this, and this is called a T distribution. If you have 10, 15, 20 data points, then you can use T distribution. Okay, so this is Z distribution or normal distribution, and this is called T distribution. That's what one sample T test, two sample T test we talked about. Okay, if you have more than 30, you can go for one sample Z test. Okay, so let me give you one example. Then I will give you some formula to calculate the the Z value and the T value and the P value, etc. And then we'll go ahead from that. Okay. Now there is one company. Let me give you a scenario here. So this company basically are they are making a product. Yeah. So Girish, it's very simple. You can draw a normal distribution, and you can normal a. So what is Z distribution? The sample size greater than or equal to 30. It is called Z distribution. And this is called T distribution, where sample size is less than or equal to 30, which is your 20, 25, 18, 10. So you can use T distribution. इतना सिर्फ आपको याद रखना है. That's it. Clear? Okay. So let me give you. So there is one company which makes some product, and they pack the product in a carton. Okay, carton is nothing but a box, right? Let's say when you purchase any electronic appliance, right? That electronic appliance is packed in a carton, in a box, right? Corrugated box. So there is one supplier of this corrugated box, and according to the supplier, okay. According to the standard, basically, you can just write this down. The standard mean here, which is the standard of the box, every box should have the weight of 1.84 kg. That is the norm by the company. So company will accept the average box weight 1.84 kg. Okay, it might be for an air conditioner or for a washing machine or something like that. Okay, imagine that way. So what they do, so one of their vendors supplies the raw material, which is the boxes. Okay, so their engineers basically check some samples. So they take out some sample. The sample size here, they have collected a sample of 64 cartons or 64 boxes. Okay, and they check the mean. So here I'm just writing down the standard mean is called as mu. You can write mu. Sample size can be called as X bar. Sorry, N. N is number of sample size, 64. Then actual mean. So once they collect 64 samples, 64 cartons, they check the average weight of the carton, and it is found to be 1.88 kilogram. Okay, and this is X bar, which is actual weight. All right, and the standard deviation, which is nothing but sigma, is nothing but 0.3 kilogram, and it can be, this is sigma, and the confidence level basically, or not confidence level, we can say the significance level. I'll explain you that. Significance level is 5%. Okay. Anyways, so everybody make a note of this. So what we do is we first calculate the Z calculated value, and the formula for Z calculated value is, everybody pull out your calculator. Just pull out your calculator and just do this calculation for me. X bar minus mu divided by sigma divided by square root of n. Can you just do this calculation for me? So we have X bar is 1.88 minus 1.84, which is our mu, divided by sigma, which is 0.3, divided by square root of 64, which will be coming at 8, right? Can you just give me the answer here? Type in the chat box. Yeah, just calculate this and give me the answer in the chat. Everybody. Yeah, just once it is done, just type your answer in the chat box. What is the Z calculated value? Yeah, everybody please calculate it and give me the answer. Don't copy the answer of others. हाँ, इन्होंने किया तो बराबर होगा. हाँ, ऐसे मत करो. Everybody calculate it. Pull out your calci and do this. Very simple calculation, guys. Very simple calculation. It is 1.066. 1.066. Everybody got the same answer? $1.066, right? एक बार कैलकुलेट करो सब लोग. 1.066 सी है. Yes, so can we round it off to 1.07? Can we round it off to 1.07? We are just rounded off to 2 digit after decimal. Okay. Yes. Now, can you just open this statistical table which I have just given in your chat? And let me also open that. Once you open that statistical table, let me know. Open. So we have calculated Z calc value, which is 1.07, right? So here I've given you statistical tables. Okay. So there are multiple statistical tables here. Okay. There are 4 statistical tables. This is called normal distribution, which is called a Z table, which we are going to use. This is T table. This is F table. And this is chi-square table. Okay. I'm just going to show you one out of this, which is a Z table. So just scroll down to Z table. Scroll down, scroll down, scroll down. Okay. Now understand this. The value which we have calculated, is a Z value. Now understand this. This is the normal distribution curve, and if this is 100%, imagine the area under this curve is 100%. Okay, imagine that. The z value, you can see here the z value here. Whatever we calculate as z, okay, whatever is area on the left hand side of the z is given here. For example, if z is this, if this is 0.5, that means it will come somewhere here. When the z is 0, it will come here. That means 50% of the area is actually under the curvature. That's why here you can see 0.500. That means nothing but 50%. Are you understanding this? Just type yes in the chat box. See, when I say z is 0, okay, you can see it is 0.0. So z0 kahan pe aayega? Yahan pe aayega, right? Exactly in the center. So whatever comes in the left hand side is 50%. So 50% area is covered over here. If z is 0. Let's say 1, example 0.1 hai. So how much area is under cover there? 0.5398. That means it will come somewhere here. And the area will be around 53.9. Almost 54% area will be covered in that. Okay. I'll just explain you, just try to understand this. Now, what is our calculated z value? The z calc value is equal to 0. What is that? 1.07 is our value, correct? So let's find out the 1 value here. So you can find out 1. Can you find out row here 1? Okay. And if I go to 0.07 here, see, so the digit before the decimal is here in this vertical column, and the digit after the decimal we have to select in the horizontal column. Understand this? Vertical column mein humko dekhna hai before decimal wala. So 1. So 1.0 yahan pe aa gaya. And after decimal is 0.7. So just check out 0.7 here. Okay. So I will just check below. So I will say the intersection is 0.8577. Everybody got this value? Just type yes in the chat box. So this is called as alpha value. Everybody understood this? Just give me yes. Z calculator we have calculated with the formula x bar minus mu divided by standard deviation divided by square root of n. When we put the values, we got 1.07 as the value. We went to the Z table and we found out the alpha value, which is 0.8577. Okay. Now listen to me very carefully. Whatever is there, आपको नहीं मिला क्या? हाँ. Okay. जिनको see, if you don't have PDF, PDF in your system, आपको ये नहीं मिलेगा. Can you just see here in the chat statistical table? Just type yes in the chat box if you have. Yes. Just click on that. It will get downloaded. If you don't have PDF reading, in your system, PDF reading document or PDF reading app, it will not open. Okay. Chalo, aage badhte. Are you clear? Now, understand this, guys. So whatever is there on the left hand side is alpha. Whatever is there on this side is called P. So what is P? P is nothing but 1 minus alpha. So what is 1 minus alpha? 1 minus 0.8577. So what will be the answer? It will be 0.143, something like that. And this is called our P value. Are you clear? So what is P? 1 minus alpha. Okay. and this is called the p-value. Clear, everybody? 0.143 is a p-value. यहां तक क्लियर है? जस्ट गिव मी यस इन चैट बॉक्स. Now don't worry, we don't have to do this manually ever. We have statistical software Minitab with us. Okay, so don't take tension. इतना सब याद रखना पड़ेगा. Not required, not necessary. Not necessary. Okay. So p value is 0.143. So what is your inference here? P low, null go. So in this case, what is the null hypothesis? Let's make a null hypothesis here. Null hypothesis क्या है? X bar sample is equal to X bar standard. Correct? And alternate hypothesis is X bar sample is not equal to X bar standard. Correct? Now the p value is 0.143. So what is your final decision on this? Do we reject null hypothesis? Do we reject null hypothesis? Type in the chat box. Sample का x bar कितना था? What was the sample x bar, which was 1.88, and the standard का x bar कितना था, which was 1.84. Correct? So p low, null go. P low, null go. So right now, is this p value lower than 0.05? Yes, the p value is not lower than 0.05. So we cannot reject null hypothesis. We have to accept null hypothesis. We have to say that there is no statistically significant difference between standard and the sample, because the p value is greater than 0.05. 0.05. So we accept null hypothesis. We fail to reject null hypothesis. So we have to say that both are almost equal to each other. Are you clear with this? Just type yes in the chat box. Now, do you want to do this with in Minitab? Do you want to do this in Minitab? Just type yes in the chat box. Do you want to do this in Minitab? Yes. चलो Minitab में करते हैं. Just take a screenshot of this. एक बार इसका screenshot ले लीजिए. If you are taking the screenshot, if you are in a position to take the screenshot, so that you will remember these numbers. Okay, हम लोग फिर Minitab में करते हैं. ठीक है? Open any Minitab file, or the last Minitab file only you can open. Open that Minitab file, the same Minitab file, the CCO, male CCO, female CCO wala. Okay? Open that. Quickly open that. We will do that once again. Okay, everybody. Now let's go to basic statistics. One sample Z test, because we have sample size 64, which is greater than 30. So we can easily take help of the Z distribution. Correct? Everybody? Just give me a second. Open this file. Just give me a second. Opened. Just give me yes in the chat box. So stat basic statistics, one sample z test. Okay. Now here, because we don't have data right now, we will have to use a summarized data. Just click on the this drop down menu. Just click on summarize data. Okay. Now, what is the sample size? Put 64. Everybody click on summarize data in the drop down. Sample mean. The sample mean was 1.88. Standard deviation is 0.3. Click on perform hypothesis test and hypothesize mean, meaning the standard mean, which is 1.84. Everybody with me? Just type yes in the chat box. Anybody behind? Let me know. Summarize data को select करो यहाँ पे. Then put 64 sample size, sample mean 1.88, known standard deviation 0.3, and hypothesize test पे click करो. Hypothesize mean is 1.84. Now go to option. Here is one setting we have to do. Go to option. Here there are three options. Alternate hypothesis क्या है right now? See, when you are not knowing whether the mean is greater, mean is smaller than the hypothesized mean, then you can simply check mean is not equal to hypothesized mean. Understand this? Mean is not equal to hypothesized mean. So if I don't know whether the mean is greater or mean is smaller, okay? But in this case, we already have calculated the mean, which is 1.88, which was greater than hypothesized mean. So I will select the mean is greater than hypothesized mean. Everybody just select the third option. The actual mean, which is 1.88, is greater than hypothesized mean, which is a standard mean, which is 1.84. Just click on this. Okay, option में आपको ये मिलेगा. And just click on OK. And now you click on OK. Everybody with me till now? Just give me yes in the chat box. Super. So here, one sample z test. And we want to check. So n is equal to 64. Mean is equal to 1.88. What was the value for hypothesized mean? 1.84. Hypothesized mean is 1.8, which is standard mean, 1.84. Okay. And actual mean, when they collected 64 boxes, they checked the actual mean to be 1.88. Okay. Now here we go. The calculated z value. Can you see here? 1.07. Just give me yes in the chat box. Z calc. We also calculated. And just find out the p value, which is 0.143. The same value what we also got, right? Super. So this is called as one sample z test. What do you want me to repeat, Adujji? Exactly. We don't have to use the... See, I asked you in the beginning, na? I asked you in the beginning, do you want to know, do you want to calculate p-value manually? So I explained you how to calculate p-value manually. If you want to do this, you can do this. But, bulb-on moment. हाँ, Minitab is better ना? अनुजी बोला चलो Minitab is better. Okay, मैं फिर से एक बार बताता हूँ. Go to stat, go to basic statistics, one sample z test. Okay, just select the summarized data. Put all the values, sample size 64, sample mean 1.88, which is the actual mean of 64 boxes. Then standard deviation 0.3. Hypothesized mean is nothing but a standard mean, which is 1.84. ये डालने के बाद go to option. And here you just have to select mean greater than hypothesized mean, because we know that the actual mean 1.88 is greater than hypothesized mean. Just select this, click on OK and click on OK, and you will find all these values calculated for us. What we are interested in, only p value. That's it. Clear? सुपर क्लियर है? जस्ट गिव मी यस इन चैट बॉक्स. अभी हम लोग, इफ वी आर क्लियर अबाउट इट, let me share with you another example, which is called pair t-test. Just download this file called pair t-test. If summarized data is not given, then we have to go for stat basic statistics one sample z test. If there is no summarized data, then we have to select which column data is there. Okay, so you will have a data, na? So you have 64 data points here. Let's say you have 64 sample data here. So you will put that column. So software will calculate the average over there. Are you clear? Then you put the standard deviation and then you put the sample, the standard mean. Clear? You can close the previous files. Yes. You can close the previous file. Let me also close this file. And okay, open this pair t-test. Open pair t-test wala file, okay? Once you open it, let me know. Now, what is pair t-test? Try to understand this. Pair t-test is used when you have, again, t-test meaning less than 30 data points. Are you clear? When we use t-test, when we have less than 30 data points. Clear hai? Now, if you have the same sample tested against two different scenarios, we use paired t-test. I will give you example. Okay. Let's say you are, you are weighing yourself in your own weighing scale at your residence and in the gym, back to back, every day. That is called pair t-test. Are you understanding? So you are common sample. You are weighing yourself in, your own weighing scale, and you are weighing yourself in the gym every day. You are doing that, and you are noting down the weight. And then if you want to check, is there a statistical significant difference between the residential weighing balance and the gym weighing balance, that is called a pair t-test, where the sample is common here. Are you understanding? Okay. The same blood sample tested again old analyzer and the new analyzer. Blood sample is common, tested against two different scenario. That is called pair t-test. Are you clear with this? Just type yes in the chat box. Have you understood the scenario in which pair t-test is used? Just give me yes. Okay. Super. Baki sab exactly same hai. What we need to do is go to stat, basic statistics. Just two sample t-test के नीचे pair t-test है. Okay. Here sample 1 में select old analyzer, sample 2 में select new analyzer and say okay. Just check the p-value. P-value says 0.003, which is lower than 0.05. P-low null go. P-low null go. That means there is a statistical significant difference between new and the old analyzer. No, not two different person. No, that will become two sample t-test, Manoj ji. Are you clear? If there are two different people, that will become two sample t-test then. The main condition here is the sample has to be common. Are you clear? Yes. So let's say another example. Let's say one cricket batsman example. Rishabh Pant. Let me give you Rishabh Pant. Rishabh Pant with some other team, and Rishabh Pant in some other team. What is the difference between the scores he scored in IPL? That will be a paired t-test. Are you understanding? The common person playing in two different teams, playing for two different teams, that will be a paired t-test. Yes? Yeah. So see, when we use paired t-test, understood? Vijay Lakshmi, have you understood the scenario when to use paired t-test? Just type yes in the chat box. Yes? Very good. So the same sequence, go to basic statistics, basic statistics, pair t-test. Okay, because we have understood the fundamentals, p-value humko check karna, that's it, nothing else. Okay, go to pair t-test. Here in the sample one, select the old analyzer, because there are two analyzers here. A blood sample is checked against old and the new analyzer. So you select old analyzer in sample one, new analyzer in sample two, and just click on OK. That's it. And just check the p-value. 0.003, which is lower than 0.05. That means there is a statistical significance. So P low, null go. We have to reject null hypothesis and accept alternate hypothesis, which is there is a statistical significant difference between new and the old analyzer. That is the conclusion. Clear है? 0.988 you've got. यही सैंपल है. अच्छा, आपने वो किया होगा, एक मिनट. Have you selected the pair t test only? ऑप्शन में जाइए. ऑप्शन में जाइए. What have you selected? We have selected difference is not equal to hypothesized difference. ऑप्शन में जाइए और alternate hypothesis is not equal to we have selected. That's it. Just select not equal to. Because we don't know what is the pair difference, right? We don't know what is the pair difference. Just select difference is not equal to hypothesize and just click on OK, and just click on OK. You will get it. Got it? Very good. Very good. Super. Yes, Girishji, the t value, there is a formula to calculate t value here as well. The same thing. The same thing. We calculate a z calc value. Remember z calc value? Same here, we calculate a t calc value. This is the value of that. यहाँ पे टी डिस्ट्रीब्यूशन है ना, तो यहाँ पे टी वैल्यू कैलकुलेट होती है, वहां पे जी डिस्ट्रीब्यूशन था, वहां पे जी वैल्यू कैलकुलेट होती है. दैट्स इट. दैट्स द ओनली डिफरेंस. क्लियर? सुपर क्लियर एवरीबॉडी? ओके, नाउ अंडरस्टैंड दिस. इफ यू हैव, हाँ, फॉर्मूला इज सेम. यस यस, फॉर्मूला जी और टी का बोथ फॉर्मूला एग्जैक्टली द सेम. Exactly the same. See, Z ka, see, they are the names, the short forms of the distribution actually. Z distribution is also called as Gaussian distribution, and the T distribution is called as student distribution. Students distribution. Okay. Yeah. Just for the information. Z is also called a normal distribution. Normal distribution, nothing but a Z distribution. Okay. Now, if you are comparing one sample with standard, it is called as, मैं यहां पे लिखता हूं, one sample t test. If you have two samples, if you are comparing two samples with each other, write this down with me. Just write this down or take a screenshot quickly. Two samples with each other. That is called two sample t test. And If you want to compare more than two samples with each other, we go for ANOVA. ANOVA is called as analysis of variance. ANOVA. Now, one sample with a standard, one sample t-test, two samples with each other, two sample t-test. Let's say 3 sample, 4 sample, 5 samples. Example. I want to compare 3 people last call, last 1 month average call time. 3 people's last 1 month average call time. I want to compare. I will go for ANOVA. If I want to compare 2 people average call time, I will go for 2 sample t-test. If I want to go for 4 people, 5 people, 6 people, I will go for ANOVA. Are you clear? Just type yes in the chat box. Are you clear with this? If I want to compare more than 2, I will go for ANOVA. Clear hai? Everybody? Just give me yes. Analysis of variance. AN stands for analysis, O for of, and VS stands for variance. Standard means custom. Yes, you can say customer specification or company standard. Okay. And here we are comparing the averages. We are comparing averages. One sample average with a standard average. 2 sample averages with each other. 3 or more sample averages. These are all called as comparison of the averages. Clear? Can you just open this file called ANOVA? We will just do ANOVA now. Okay, have you opened the file? ANOVA wala file open kiya aapne? Just give me yes in the chat box. Super. So just see the scenario. There is a Mercedes showroom. Okay. And they call it as zone. Okay. Zone 1 showroom, zone 2 showroom, zone 3 showroom. And this is the average time in hours to service one Mercedes car. Okay. So 5.3, 5.2, 5.3, etc. So what actually we are comparing here is average of the first zone. So software will calculate the average of this, which is x1 bar, then x2 bar, x3 bar. So there are 5 zones basically, x4 bar and x5 bar. Okay. So null hypothesis will say all are exactly matching. The averages are equal to each other. And alternate hypothesis will say that either one has different mean, or at least they have a statistical significant difference. Okay. So how do we calculate the formula? The procedure remains same. Let's go to that. Go to stat, ANOVA, one way. Everybody follow this. Stat ANOVA one way. ANOVA is a short form of analysis of variance. Stat ANOVA one way. Click on that. Now, here the response is nothing but our lead time. Okay, lead time response में lead time को select करना है. And what is the factor is nothing but a zone. So what we are checking here, is there any difference because of the zone, right? So the factor here is the zone. So we have to select zone in the factor. All right. And I think rest of the things are okay, and click on OK. Everybody got it? Stat ANOVA one way. Response में lead time and factor में zone select करके just click on OK and you will get this graph. Got it, everybody? What is your reading of this graph? Type in the chat box. What are you observing in this graph? Type in the chat box. Everybody. What are you observing here? Average is different. Zone 2 is having some difference. Very good observation. Zone 2's variation is very high. Very nice. So if you see here, zone 1, 3, 4, and 5 are very close with each other, whereas zone 2 ka average is very high. You can see here. So there is a difference, right? Let's check out our p-value. What is our p-value here? How do we find a p-value? Go to the sessions window, sessions folder pe click karo, and just scroll it up, and just check the p-value here, 0.018. What is my p-value? 0.018. That means it is low, p low, null go. That means there is a statistical significant difference between at least one zone. Yes or no? And we can easily find out here. If you see the means here, 5.3, 5.44, 5.44, 5.3, 5.26, 5.20. So 5.44 is having the highest amount of mean, which is the average. So zone 2 is clearly indicating that there is a statistical significant difference. Are you clear? Just give me yes in the chat box. Everybody with me? Now let's do one thing. Let me just try something different here. Zone 2 के data को ही उड़ा देते हैं यहां से, ठीक है? So what I'm doing is I'm just deleting the zone 2 data. Okay? And I'm just cut and paste the other data cell, okay? Clear? So what I've done is I've just eliminated the zone 2 data. I just do the same thing once again. And let me say, look at this. So there is no much difference between the remaining 4 data points, which is 1, 3, 4, and 5. Not much difference. Let me check the p-value here. If I scroll up, the p-value is 0.864. That means it is much greater than 0.05. So I can confidently say that the p-value is high and there is no statistical significant difference between these 4 zones. Only zone 2 is having the problem. So what I'll have to do, I'll have to focus on zone 2 and do some project to reduce the average, average servicing time of the car. Are you clear with this? Just type yes in the chat box. Clear hai? Super clear? Very good. What is F value? Very nice. What is F value? F value is nothing but basically, so here you need to actually learn this analysis of variance table. Okay. Now, in this analysis of variance table, okay, if you are interested to know about it, just for for your reference, if you're interested, okay, I will give you a very good resource here which you will love. Okay. And what if and this is the resource, okay, what if, let me go back to my Minitab software. What if I explain you all these parameters, okay, all these parameters with formulae. If you want to know about it, click on the link. Of course, not now. You can just copy this. This is already available in the masterclass archive. The name of the topic, if you go to masterclass archive, you just have to search ANOVA table or ANOVA table decoded. ऐसा कुछ तो है. Okay. There I have decoded each and every element on Excel sheet with the formulae. Okay. So what is this? Adjusted SS, ADJSS meaning adjusted sum of square. DF meaning degree of freedom. ADJSS meaning adjusted sum of square. ADJMS meaning adjusted mean square. F value is nothing but this divided by this. Iska ratio hai ye. F value. Okay. And from the F value, software refers the F table, which I have already given to you. I have given you Z table, P table, Z table, F table, chi-square table, T table. So software takes help of F table, and on that basis, software calculates the P value. And how it is calculated manually, I have explained that in that scenario. Clear? But it is not required for the black belt level. It is actually required in the master black belt level. But if you are interested, you can go ahead and check out that. ठीक है? हाँ, एग्जैक्टली द सेम प्रोसीजर मैंने जो लिंक दिया है ना, उसमें एग्जैक्टली एक्सेल शीट पे कैलकुलेट करके दिखाया हुआ है. क्लियर है? यस, कॉन्फिडेंस लेवल 95% ही पकड़ा जाता है, अनलेस एंड अनटिल स्पेसिफिकली स्पेसिफाइड. 95% ही कॉन्फिडेंस इंटरवल पे हम लोग पकड़ते हैं. ठीक है? You can change that if you wish. You can change that. How do you change that? You can go to option, and here confidence level है ना, यहाँ पे आप change कर सकते हो. If you want 95, let's say you have less amount of sample size and your confidence level, we want to check it on 90%, then you can check accordingly. When confidence level is 90%, P value has to be checked on not 0.05 but 0.1. See, confidence level plus significance level is equal to 100. If confidence level is 95%, significance level is 5%. P value is attained significance level. Attained nahi, attain. Attained SL is nothing but P value. If confidence level is 90%, okay, significance level becomes 10%. So P value has to be tested with 0.1 and not 0.05. Are you clear, Preeti? Yes, very good, very good. Super. See, confidence level is nothing but, in simple word, confidence level is nothing but what is my confidence on this prediction about my behavior of the population. And generally it is kept at 95% only. We don't do any changes in 95%. Are you understanding? So confidence levels are fixed at 95%. unless and until you have very limited amount of sample size, etc., you can reduce the sample, you can reduce the confidence level that I'm not confident about the prediction. In that case, your confidence level reduces. But otherwise, it is not recommended to do such kind of thing with the less samples. Clear? ANOVA clear hai? Just give me yes in the chat box. Logic is very simple. When we basically, there are some, you have to go back to the sampling methods. You have to go back to the sampling strategies. Okay. If we are not using, for example, very simple sampling, very thumb rule sampling strategies, square root of n is very famous sampling strategy. For example, let's say when I'm making 100 pieces, I take square root of n is equal to 100. So I will take 10 samples. Okay. And then I will predict about the behavior of these 100 pieces. These kinds of strategies, if you are not using, let's say you say, I don't have 10 samples, I will take only 2 samples. So predicting on the basis of 2 samples about 100 samples, 100 pieces will be very difficult. That in that case, you should actually reduce your confidence level, because you have less confidence about your population. More the sample size, more will be the confidence. It's very simple logic. Logic is more sample size, more the confidence about a population, right? Less the sample size, less will be the confidence about the population. That's the funda behind it. Okay. Just give me yes in the chat box. Good. Okay. Now let me just take you to one of the table, which is very important. Now, some of it we will cover today itself, according to the time permission. Okay, look at this. So this table is already available in your black belt hypothesis testing. Now, what we have covered till now is see, there are 3 types of hypothesis testing. One is called hypothesis of the means, which is nothing but whenever we have the distribution, if you want to compare the mean of one distribution against the mean of the second distribution, that is called a comparison of the means, x bar A and x bar B. That is the comparison of the means. So in the mean comparison, we have 1 sample t-test, 2 sample t-test, pair t-test, and ANOVA. We have seen these 4. 1 sample, 2 sample, we have already studied in the green belt level. 2 sample, I have already given you example of male CCO and female CCOs. Okay. Pair t-test also, old analyzer, new analyzer. And this one, example of ANOVA we have taken, right? This is for the mean. What about the the second one is called the variability. See, we can compare the variation as well. Variation of first sample or the first data with variation of the second data. Okay. Now variability can be checked in either in standard deviation or variance, correct? So if we are comparing variance of sample A is equal to variance of sample B, that's where the variability comes into picture. If you are checking 2 samples, that is called F ratio test. If you are checking more than 2 samples, like 3 samples, 4 samples, that is called test of equal variance. Okay. So F ratio test is when you are having 2 samples, and test of equal variance, you are having 3 samples, 4 samples, 5 samples, like that. Are you clear? That is where the variability. Then comes the proportion. What is proportion? Let's say you want to compare, let's say proportion defective of shift 1. Okay. Let's say there is a proportion defective of shift 1. So I would say P1 and proportion defective of P2 if you want to compare 2 shift. So if you are comparing 2 proportion, that is called as test of 2 proportions. And if you want to compare, let's say 3 proportions or 4 proportions or 5 proportions, etc., it is called as chi-square test. When you are comparing more than 2 proportions, that is called chi-square test. Are you clear with this? When do we use which? Hypothesis testing. You need not to remember this. Whenever it comes, just check this table and decide which hypothesis testing you want to use. Are you clear with this? Just type yes in the chat box. Yeah, which one you want me to repeat, Anil ji, Arvind ji? Mean clear hai? Mean is clear. If you want to compare the mean of 2 or 3 samples, then these are the, variability. In the data set, there is a mean, which is the average, and there is variability, right? Standard deviation, variance, which measures the variation. If you want to compare variation of one with another or two with another, right? If you want to compare two samples variability, that is called F ratio test. If you want to compare more than two samples, that is called test of equal variance. Are you clear with this? If you want to compare the variation, which is variance, sigma square, or you can compare standard deviation. Clear hai ye? Very good. Now come to proportion. Proportion, when do we use? Let's say proportion defective. Okay. In first shift, how many defective? Let's say proportion defective, proportion absenteeism. Out of 50 people, working people, how many absent? It's a proportion, right? Now you want to compare two proportion shift 1 and shift 2. That's where we will use test of two proportion. And if you want to compare 3, 4, 5 proportions, then you go for chi-square test. Clear when you are going for proportions? Clear hai? Just give me yes in the chat box. So mean, variability, and proportion. These are the three different types of hypothesis testing we are using. Okay? Very good. So now let me go for F ratio test. F ratio test को मैं एक बार आपको दिखाता हूं. See, in your curriculum, we have given you all the formulae, all the calculation, all the screenshots. ये देखो आपको screenshots भी दिए हुए. So you don't have to. यहाँ पे देखिए old analyzer, new analyzer, go to stat, basic statistics, pair trade. इतना basic करके दिया है. Okay? 15-minute break. Yeah. In 5 minutes we'll break for 15 minutes. Okay, रविंद्र जी. 10 मिनट का ब्रेक लेते 10 मिनट का ब्रेक लेते ठीक है. एक बार ये ये जो कंपेयर करता हूं मैं, देन वी विल टेक द ब्रेक. ओके, एनोवा भी है. नाउ टेस्ट ऑफ वेरिएंस हम लोग करेंगे वेरिएबिलिटी के लिए एफ रेशियो टेस्ट. ओके, वेयर वी यूज एफ डिस्ट्रीब्यूशन. नाउ हियर ये एक बार फटाफट कर लेते हैं, देन वी कैन go for the break. Okay, see, once you know the fundamentals na, it is super easy for us to understand. Okay, now this is the F test. Okay, or F ratio test. What is F ratio test? एक example लेते हैं. Random sample size of N1 12 and N2 16 are drawn. Okay, so यहाँ पे है N1 12 and N2 16 are drawn from two population. The sample standard deviation is found to be, standard deviation is 145 and 82. Okay, you can make a note of this, or I have noted it. I will make you understand. So what is there? एक है यहाँ पे और दूसरा है यहाँ पे. इसमें है n is equal to 12, इसमें है n is equal to 16, इसमें है standard deviation sigma is equal to 145, इसमें है standard deviation is equal to 82. Now you want to compare what we want to compare here. So null hypothesis क्या है इसमें? Sigma of first one is equal to sigma of second one, and alternate is they are not equal to each other. Okay, very simple. So how do we do that? It is called as test of equal variance, right? So how do we do that? So you can just check here. So मैं भी करता हूं आपके साथ ही. चलो मैं भी just open any file, any Minitab file. अभी का एनोवा का भी यूज किया तो भी चलेगा. The same Minitab file. Go to stat, basic statistics. Test of two variances. which is called F ratio test. Go to stat basic statistics, two variances pe click karo, everybody. And we have to manually enter the data. So up any file you can open and do this. Whatever you have done ANOVA, the same file you can use. Stat basic statistics test of this one, two variances. Okay. Just click on that. Here both samples are in one column, so we don't have anything. So go for summarized data. यहाँ पे कितना है हमारे पास स्टैंडर्ड डिवीजन सैंपल स्टैंडर्ड डिवीजन है सो राइट जस्ट क्लिक ऑन सैंपल स्टैंडर्ड डिविएशन ड्रॉप डाउन में सिलेक्ट सैंपल स्टैंडर्ड डिविएशन सो सैंपल साइज 1 is 12 write this down sample size of second is 16 standard deviation of first is 145 standard deviation of second is 82 now we want to compare is there any statistical significant difference between these two standard deviation just click on OK. Now you can see here the p value is 0.043 0.043 what is your conclusion what is your conclusion type in the chat box Pilo Nalgo right yes Pilo Nalgos that means there is a statistically significant difference between these two these two variances, these two standard deviations. Are you clear with this? When you want to compare two variances, two standard deviation, this strategy has to be used. Clear? Just give me yes in the chat box. All right. Now, let's do something very interesting. Let's go back to the same ANOVA wala example. Okay, the same file of ANOVA. Can you just open ANOVA wala file? In this ANOVA wala file, you remember first we calculated. If you remember, we calculated ANOVA, which was the average of the first sample, average of the second sample, etc. Right? Average of the third sample, average of the fourth sample. Correct? It was ANOVA wala thing. Correct? Now, instead of average, what happens if we take the variance? If we take variance of first, variance of second sample, variance of third sample, and variance of fourth sample. If you want to compare the variances of this, okay, we'll go for test of equal variances. Test of equal variances. All right. Now, how do we do that? Go to stat ANOVA test of equal variances. Just follow this. Stat ANOVA test of equal variances. Just click on that. Now here the response is in lead time. Double click on lead time and the factor is nothing but a zone. And just click on OK. And both cases, just check multiple comparison 0.8. P value is 0.8. What does it mean? What does it mean? So P value is greater than 0.05. So the null hypothesis cannot be rejected. So there is no much difference between the variances of all the four zones. Are you clear with this? Just type yes in the chat box. Clear hai? Yes. Super clear. वेरी गुड, वेरी गुड. चलो अब ये काम करते हैं. फर्स्ट वी विल टेक अ क्विक ब्रेक and then we will continue discussing this. Okay. So there are two more hypothesis testings are required, and after that remaining, and then we'll go for the regression, advanced regression today. Okay. Yes. It is 8:37. We'll be back by 8:47. Okay. Chalo, let's enjoy your coffee or tea. Let's take a quick break. Yeah. All right, so welcome back to the second section of today's session. And of course, as we go a little, what you can say, advanced in the tools initially, and a lot of people are new in the room. For you, it will be a little difficult to grasp everything at one glance. Okay, so my recommendation is give time some time. Okay, so go very slow, have some patience, and you will eventually come to know. All the dots will get connected once you go through the green belt curriculum, black belt curriculum, and hackathons parallelly. All the dots will get connected easily. Okay, so let me just share my screen here. So, here we go. So we have covered the mean, which is one sample, two sample pair t-test ANOVA. We have covered variability, F ratio test, and test of equal variances. Now let's focus on the proportion. Wherever you want to compare the proportions. Okay, so let's compare the two proportions. That is called test of two proportions. I'll give you a classic example for this. A corporation's purchasing manager. So there is a purchase manager of the corporation, and they need to authorize a purchase of 20 new photocopy machines. So they want to purchase some Xerox machine. Okay, so after comparing many brands in terms of price, copy quality, warranty, features, etc., they have narrowed to two. Okay, brand X and brand Y. Understand this? So brand X and brand Y, they have compared. Okay, they have identified, because it's a big company and they already had some machines like this. Okay, so they want to check the performances of X and Y brand. So because the corporation already used both the brands, he was able to obtain information. So random sample of 50 machines of each brand were selected. Record indicate that 6 of brand X machine and 8 of brand Y machines needed services. So here is, that means total. So X brand, total we have 50 machines, out of which 6 machines are failed basically. So in other words, 44 machines are running proper. Okay, and what about brand Y? 8 machines required the services. That means 42 machines are basically running okay. All right, so 44 out of 50 or 42 out of 50, this is a proportion. Now we want to compare. So null hypothesis, so null will be they are equal, and alternate will be they are not equal. Are you clear? So we want to compare this proportion. Are you clear with this background? Just give me yes in the chat box. Clear hai? You can open the same Minitab worksheet which I have given to you this earlier, whichever earlier worksheet you have. You can just open the same worksheet, or any worksheet for that matter. Okay. Yeah, open. Go to stat, basic statistics. You can see here two proportion data. Stat basic statistics, just where we use one sample t-test, two sample t-test, there you will find a two proportion. Just click on that. Now just drop down, just check what are the options available. Both samples are in one column, each sample in its own column, and summarize data. Because we don't have data, we have to key the data in. Just go to summarize data. Okay, just go to summarize data. So here the number of events. What is the number of events here? We saw the first one are 44, and total number of trials are 50. So the first number event is 44 and the second is 42 out of 50, right? So this is the proportion we want to test. Correct? So number of trials are 50. So they have taken 50-50 each, out of which 44 they found it to be okay. 6 requires some repairing. And the second one, 42, they found it to be okay, and 8 requires repairing. So they just want to compare the proportion. Just click on OK. All right. And here is the test of equal variance. 0.564. What is the conclusion here then? What is the conclusion? 0.5 hai, not 0.05. Okay. So it is greater than 0.05. So we fail to reject. See, P low null go na. See, P low, if P value is lower than 0.05, we reject null hypothesis. Okay. So here in this case, we fail to reject. So there is no significant difference between proportion 1 and proportion 2. Okay. So as a purchase manager, you can go for any machine. All right. Any machine purchase, because there is no statistical significant difference between the proportion failure. Are you clear? Just type yes in the chat box. All right. And the last in this is called chi-square test. हाँ, फिशर्स एग्जैक्ट टेस्ट नाम का एक टेस्ट होता है विच वी डोंट यूज एक्चुअली. हाँ, डिफेक्टिव प्रोपोर्शन भी चेक कर सकते हैं इसमें. यस, बोथ द प्रोपोर्शंस वी कैन चेक. डिफेक्टिव भी कर सकते हैं, ओके प्रोपोर्शन भी चेक कर सकते हैं. ऑलराइट, सुपर. कैन यू जस्ट check this file called chi-square test. Okay, and let me explain you what is the scenario here, and then I'll explain you how this chi-square is calculated first. Okay, and then okay, just check here first. So we want to check here if the shift has an influence on the number of customer complaints. Okay. So we are comparing, there are 3 shift operation, and there are number of different types of defect or customer complaints which are coming. So is there any shift wise variation there? That we want to compare. So more than 2 shifts are there. That's what we are going for chi-square test. Okay. So null hypothesis says shift has no effect. Alternate says shift has some effect on the defects or the customer complaints. Okay. So here we go. Let's see the data here. So what we do is we collect some data. So this is the data. In this column, you can see shift 1, 2, 3. And in the horizontal axis, they have given defect A, defect B, defect C, defect D, etc. All right. And let's say, for example, in the first shift, there are 15 A defects, 21 B defects, 45 C defect, and 13 D defects. Similarly, second shift and night shift, they have collected the data. हाँ, गिरीश जी चेक करके देखिए. नाउ यू कैन एक्सप्लोर योरसेल्फ. रिजल्ट सेम आएंगे कि नहीं, चेक करके देखिए क्या आता है रिजल्ट, और मुझे भी बताइए व्हाट इज योर लर्निंग ऑफ दैट. ओके, पहले लेट्स फोकस हियर. ये होने के बाद देन यू कैन go back to the proportion defective वाला thing, and you can just put the defective data and check the result. Okay, और मुझे भी बताइए, सबको बताइए. Okay, now coming back to this, have you understood the data? Just give me yes in the chat box. Now we want to compare whether the shift has any impact on the defects. Yes, clear hai? Now how do we calculate this? Again, let me explain you it manually first, but we never have to use it manually. Okay, we never have to use it manually. Okay, we have the software, super software Minitab with us. But how manual calculation is done? First, they calculate the expected value. Understand this. What is expected value? Expected value is nothing but row total into column total divided by grand total. Now, what is row total? Row total, let's say, for example, if I want to check expected value of 15, let's say, Then what is the row total here? 94. Can you see here? What is the row total? Row total is 94. And what is the column total? Column total is the vertical total, which is 74, which is 15 plus 26 plus 33 is equal to 74. What is row total? 15 plus 21 plus 45 plus 30 is equal to 94. So row total plus column total. What is grand total? If we add all the row totals and all the the column totals, you will get the row final grand total. It should tally. Row total and column total should tally to each other, which is the grand total. Are you clear? Are you clear with this? Just give me yes in the chat box. Okay, let's do this. एक करके देखते हैं. So expected value for 15. Okay, so expected value EV for 15 किस प्रकार से कैलकुलेट होगा? Which is row total क्या है? 94. Everybody multiply by 74, which is column total, divided by grand total 309. Can you just calculate it, guys? Row total 94 into 74 divided by 309. Can you just do this calculation? Very good. 22.51. This is expected value of this. This is actual value 15, but expected value is 22.5. So we have to calculate expected value of each and every data put in here. Okay. So of course we are not going to do it. Software will do it for us. Look and see here. 94 into this is 22.51. So your calculation is absolutely right. Okay. So here in the table they have calculated this. Okay. So like this, expected value of 15 was 22.51. Similarly, expected value of 26 was 22.9. Then 33 के लिए था 28.5 and so on and so forth. ठीक है? Once that is calculated, then they calculate the actual chi-square value. What is chi-square का formula? This is called chi-square. It looks like X. Okay. So it looks like this. Again, this is a what you can say, this is chi-square. Chi is nothing but our Greek letter, just like alpha, beta, theta. Chi is also Greek letter. So what is the formula? Summation of observed minus expected. Observed means the actual minus expected, what we calculate. 22.51 is expected value divided by expected. Okay. And observed minus expected का square, deviation का square लेना है. And all you have to sum it up. Okay. For example, like this. So the first one will be chi-square is equal to 15 minus 22.51 square divided by 22.51 plus 26 minus 22.99 square divided by 22.99, and ये सब करके जो value आएगा 19.918. That is the chi-square value. Then they will go to chi-square statistic, chi-square table, and they will calculate the p-value for it. Okay. So I have already given you the chi-square sheet. Can you open the chi-square sheet here? We will calculate the p-value quickly. एक बार कर लेंगे, then we will go to regression and then close the session. Okay. Open the chi-square value. Everybody open that. Just give me a in the chat box. So we are going to focus on this. This is the exact value what I have just shown you. Same value यहाँ पे है. Shift 1, Shift 2, Shift 3, A, B, C, D. First value was 15, which we calculated. Okay, same है. How do we do that? Go to Stat, Tables, Cross Tabulation, chi-square. Just follow this path. Or a little different path here. Stat, Tables, Cross Tabulation, chi-square. Okay, once you click on that, so here there are two options: row data, categorical variables, and the second option is summarize data in two-way table. So we have to select summarize data in two-way table. Just drop down this and just select summarize data in two-way table. All right. In the column containing table, select A, B, C, and D. Select A, B, C, and D. Or you can select it manually as well, like double click on A, double click on B, double click on C, double click on D. A, B, C, D को select करो. And rows में shift को select करो, shift number को नहीं. Okay. In the rows, here in the rows, just select shift, not shift number. Huh? C1 is shift number. See, we are not considering C1 and C2. We are only considering C4 से C8 वाला table. Okay. That's why select shift. Double click on shift. All right. Once you have done, just go to chi-square. Chi-square पे click करो. Select chi-square test and select expected cell count. Chi-square test and expected cell count. Click on OK and click on OK. And here is your Pearson chi-square value, which is 0.004. So P value is less than 0.05. That means P low null go, you have to reject null hypothesis. It is less than 0.05. That means there is statistical significant difference between the shift. And now if you see here closely, you will observe here this table closely. Okay. The first shift here, let me write it here. First shift we have 94 defects. Second shift we have 96. And the night shift we have 119. So which is the culprit shift here? The shift number 3. So anything which has to be done in shift number 3, which is night shift. Are you clear with this? Just type yes in the chat box, because night shift overall defects in all these areas are seen to be a little more than the other defects. Clear hai? Just give me yes in the chat box. This is called chi-square test, where you want to compare, more than 3 shifts or 3 people or 3 vendors or 3 proportions, whatever 3 proportions. Okay. How do we get to this screen? Just click here. Just click on the sessions window. You will come to this screen. Chi-square test, MTWs, Minitab worksheet. यहां पे देखो सेशंस विंडो. इसका शॉर्ट फॉर्म है Control Alt M. Control Alt M, which is sessions field window. But we are interested in just the P value. This one, the Pearson's chi-square value, which is 0.004. That means there is a statistical significant difference between the shift. And the third shift is clearly visible. So we have to focus on the night shift and improve and reduce their customer complaints and the defects. Clear? Just give me yes in the chat box. Are you clear with this? Super clear hai? सच्ची क्लियर है कि थक गए हो इसलिए? हाँ सर क्लियर है, क्लियर है. What is our base for pinpointing the shifts? See, if you see the data, third shift is having 119 customer complaints, or the defects rather. Shift 2 is 96 and shift 1 is 94. That's the point number 1. Okay. Okay, you have not got the chi-square values, because if you go back to this, okay, go back to this, go to chi-square. Dr. Gupta, just follow this. Go to chi-square here. Once you fill A, B, C, D and shift, click on count, just go to chi-square. Here you have to select chi-square test. You have to click on chi-square test and check box on expected cell count. ये भी आप check कर सकते हो. Actually, it is not that, Actually, it is not that what you can say difficult. Okay, I'll explain you once again. क्लियर है? एक बार ओके करके देन ओके करिए, देन आपको वो काई स्क्वायर के रिजल्ट आएंगे, वैल्यूज आएंगे. जस्ट करके देखिए एंड गिव मी द कंफर्मेशन. हाँ, अभी यहां पे फोकस करिए, यहां पे फोकस करिए. व्हाट आई वाज टॉकिंग अबाउट हियर इज, ओके, whenever, first of all, remember this, just remember in structure. Okay, whenever we are talking about hypothesis testing, there are three types of hypothesis testing. One is mean, which is maximum used. Second is variability, and third is proportion. यहां तक everybody with me? Just type yes in the chat box. Yes, everybody, focus here. Hypothesis testing में there are three things. One is if you want to compare the mean of one with mean of other, then you will do one sample t-test, two sample t-test, a pair t-test, ANOVA. Mean का हो गया. Very simple. So you have to select according to your scenario. You just have to put the data and select the test. That's it. Understand this? You don't have to remember this table. Don't have to remember this table. Table is already available with you. Only mean, variability, and proportion. These are the three hypothesis testings we have. Okay. The simple thing is that collect the data, select which test is applicable, feed the data, select the test, and check the p-value. That's it. Okay. Now, variability. Variability is nothing but the variation, right? Let's say this is one variation and this is second variation. Now you can see here, variation of A is less than variation of B. But is it statistically significant? Then you check the p-value. That's it. You can make out with the standard deviation, you can make out with your variance, but is it statistically significant difference? That is what the p-value is talking about. So we collect the data, feed the data in the software, and software will give us the p-value, which will confirm that, yes, whether it is statistically significant or statistically not significant. That is what is nothing but the hypothesis testing. That's it. Nothing else. Clear hai? Vijay Lakshmi ji, are you clear with this? Just give me yes in the chat box. Simple. Just collect the data, feed the data in the Minitab software, and check the p-value. Just check the test. Which test will be applicable? Is it the mean? Is it variability? Is it a proportion? That's it. Itna hi hai. I went deeper. Why you got a little confused? Because I went a little deeper. I would have said that, okay, just select the data and select the accordingly test, check the p-value and infer. I could have summarized the hypothesis test like that only. But we went a little deeper. Okay. Initially, when you found it a little difficult, that means you have learned something new. How many have got the bulb on moment right now? Just type BO in the chat box. Whenever you say difficult hai, that means this is first time you are experiencing. That means you are learning something new. If it is easier, that means you have not learned anything. How to decide which test needs to be performed? You can see this table. See this table. Let's say, for example, let's take simple example here. Okay, I want to select. I am a cricket selector. Okay, and I want to select one wicket keeper batsman, and I have two options. One is Rishabh Pant, one is KL Rahul. So I will collect the data of Rishabh Pant, I will collect the data of KL Rahul, and I will check the batting average. I will do for two sample t-test. Yes or no, everybody? Everybody, are you with me? I will go for one sample t-test. Let's say selection committee decides wicket keeper batsman should have average above 40 runs. So this is my standard. So I will collect data of Rishabh Pant. I will test with the standard, that is called one sample t-test. I will collect the data of KL Rahul. I will check with the standard, that is called one sample t-test. Let's say I want to check Rishabh Pant. how Rishabh Pant is performing with LSG and how he's performing with CSK, Chennai Super Kings. Okay, same person, same sample with two scenarios, pair T test. Now there is a third wicketkeeper batsman. Let's say Sanju Samson. Now I have KL Rahul, I have Rishabh Pant and Sanju Samson. Who do I select? I will go for ANOVA. Are you clear with this? Because I'm collecting the averages. One sample, two sample, paired and ANOVA. Are you clear? Just give me yes in the chat box. I've just given you very simple example. Clear? Now, let's say there is not much difference between averages. Okay, not much difference. I want to compare the standard deviation. See, average might be same. Let's say this is KL Rahul and this is Rishabh Pant. Averages are exactly same, but variation is there. Now this is Pant and this is Rahul. So I want to compare the variability. If I want to compare the variability of Pant and Rahul, it is F ratio test. Two variances I will compare. Variance of Rahul, variance of Rishabh Pant. That is called F ratio test. Now I want to compare more than two. You can see here more than two, which is Rishabh Pant, KL Rahul and Sanju Samson. I will go for test of equal variance. Are you clear? Just type yes in the chat box. Clear hai? Now with the same example, I'll go to proportion. Now I want to select a captain. I have two options. I have Hardik Pandya. I have Rohit Sharma. So I will select the proportion of victories. Let's say Hardik Pandya has done 50 matches. He has led and he has made 30 victories. Rohit Sharma has led 40 matches and he has made 28 victories. So there is two proportions. So I will go for test of two proportion. Now I have got third option. Let's say MS Dhoni. So I will go for chi-square test. I want to compare three proportions. Are you clear with this? Simple. How many of you are clear now? And simple. Collect the data, feed the data, check the p-value. That's it. No tension. Super clear. हाँ अभी क्लियर हो गया. Yes. Now it is clear. So cricket का ही example देना चाहिए था. Yes, very simple. So accordingly you decide which test is required to be done and you select that. Select the test, feed the data, check the p-value and infer. That's it. Okay. चलो आगे बढ़ते हैं. All right. So we'll cover today some part of regression. Okay. If possible. Otherwise we'll cover it tomorrow. Okay. So have I shared a file with you of regression? If no, I am just sharing the file again with regression. The name of the file is curvilinear regression. Okay, regression everybody knows, which is predicting the value of one variable with another variable. It's called regression. All right. So let me open also. Okay, once you have opened it, let me know in the chat box the file is open. मैं इसको बंद कर देता हूं. जो फाइल नहीं चाहिए उसको बंद कर दीजिए, so that you will not be miss out in messed up with this file, because a lot of files we are handling, right? Super. चलो open कर रहा हूं. Once it is open, let me know. Done. Done. Okay. Open. So meanwhile people are opening. So we have a data of, there is a dosage in milligram. MGM में dosage है, and what is the comfort level on the scale of 1 to 10. Okay. So this is comfort is our output, which is Y, and dosage is our X. Now before that, if you remember, we have studied correlation. We all have studied correlation and regression in the green belt. Okay. So I'm speaking with the green belt certified people and who are into the black belt, and not to the new people. Okay. Considering you guys are green belt certified and you are into the black belt. Okay. So I'm speaking to them. So we have correlation and you have regression. What is the difference? So correlation meaning establishing relation with X and Y, and regression meaning predicting the value of one, or you can say predicting the value of X on the basis of Y and vice versa. So what is correlation? Establishing relationship between X and Y. Okay. For example, so you have majorly three types of correlations. One is called positive correlation. When your X is increasing, your Y is also increasing. It is called positive correlation. When your X is increasing but Y is decreasing, it is called negative correlation. Right? And when X is increasing, there is no impact on the Y. X is increasing or decreasing, there is no impact on Y. It is called no correlation. Yahan tak basic funda clear, everybody, which we have studied in the green belt as well. Plus we have studied Y is equal to A plus BX. Yes, R square value, which is the strength of relationship. Everybody remembers this? Yes or no? Super. Quantifying, giving the value to the correlation. So correlation is just establishing whether it is positive, negative correlation hai ki nahi. Regression meaning, in regression we get the equation, the regression equation, Y is equal to A plus BX. Okay. With the regression equation, we can predict the value of one, predict the value of any X in the given range of the values. We can predict any value of X with the help of Y, or we can predict any value of Y with the help of X with the regression equation. So we can predict the value with the help of regression. Okay. So correlation is establishing relationship and regression is predicting the value of X and Y with respect to each other. Okay. Now let's open this file, which is comfort and this one. Now we will just do one. First we will do a scatter plot. एक बार scatter plot करके देखते हैं. Graph open scatter plot. Simple scatter plot करके देखते हैं. Graph में scatter plot है. In the Y select comfort, in X select dosage and say OK. Wow, this is something interesting. ये कुछ तो अलग ही है. ये ना ही is it positive, negative, क्या है ये? What is this relationship? Type in the chat box, everybody. Is it positive? Is it negative? Yes. Is it positive? Is it negative? What exactly it is? Sir, आपने तो तीन ही बताए थे, ये तो चौथा है. So तीन बताए थे, which was in green belt. Now we are in the black belt, थोड़ा सा advance. This is called as curvilinear relationship. What is that? Curvilinear. You can see a curvilinear. Correct? So initially it is showing a positive behavior. Here it is showing positive. Here it is showing a plateaued behavior. And here it is showing a negative trend. Yes? So it is neither positive, neither negative, but it's called curvilinear. Example, I'll give you example of this. Imagine I'm making a cup of tea. As I'm increasing, okay, imagine there is no sugar into that. Sugar is 0. So on the x-axis is sugar. So initially there is no sugar. So the test will be very low. Then I started adding half a tablespoon sugar. So I'll get some test. Again, 1 tablespoon, some test, 2 tablespoons. After that, the test will be plateaued. If I keep on adding sugar, the test will get deteriorated. वो गुलाब जामुन का वो ये होता है ना, छासनी होती है ना वो, that the tea will become like that, right? It will be too sweet. Yeah, it will be too sweet, isn't it? So this is called a curvilinear relationship. Another example, the rainfall and the rice production. Because the rice requires huge rainfalls, initially as the rainfall increases, the rice production increases. But if the rainfall continues to increase, then the rice production goes down as well. Excessive rainfall also is harmful for the crops, right? So this is called a curvilinear relationship. Clear hai? Now, this is called correlation. Let's do a regression analysis here. Let's go to stat, regression, fitted line plot. Can you just do this fitted line plot? Stat regressions fitted line plot. In the response variable, select Y is our comfort and X is our dosage. Okay, and click on OK. So we can see, Y is equal to A plus BX. R square value is 1.5. Very poor relationship hai R square ka. Okay. And this is Y is equal to A plus BX. Right? Now let's go back. Everybody with me till now? Just give me yes in the chat box. So correlation, we have seen the correlation, which is scatter plot, and regression, the linear model. This is called linear model. Clear? Just go back here. Go back to this edit last dialog box. Instead of linear, just select quadratic now. Just select quadratic and click on OK. Wow. Can you see here something different? Now the R square value had changed to 69.9. Earlier it was 1.5. Now this model is much better than the earlier model. But now this is not Y is equal to A plus BX. This equation is Y is equal to A plus BX B1X, you can say, plus B2X square, where B1 and B2 are the different slopes in this equation. A is equal to intercept. B1 and X2 are, B1 and B2 are the slopes, and X remains our X, which is our dosage. So this is called as quadratic. हाँ, मैं रिपीट करता हूं. The same steps. Go back to stat, regression, fitted line plot. Everybody follow this. Stat, regression, fitted line plot. Select comfort in Y, which is our output Y. X is our dosage. Select X. And first you do linear. Click on OK. After that you do go to quadratic model and click on OK. तो आपको ये दोनों भी ग्राफ मिल जाएंगे. Then once you do that, just go for cubic and click on OK. Look at this. So R square value here has 69.9 से थोड़ा change होके 70% हो गया है, which is the highest R square value. Now write this down. Linear model क्या होता है? Y is equal to A plus BX. Write this down. Quadratic model क्या होता है? Quadratic Y is equal to A plus B1X plus B2X square. And what is the cubic model? What is the cubic model? Y is equal to A plus B1X plus B2X square plus B3X cube. This is called the cubic model. And whichever highest R square value, that model we have to select. In this case, the cubic model has the highest R square value. So we are selecting this model. So highest R square value means this model can predict the value more precisely. Are you understanding? More precisely. Not required. Sometimes, because this is a curvilinear regression, that's where cubic models are having more R square value. imagine you have a straight line equation. So linear model will fit more than the cubic model. Are you clear? So you have to select whichever is the best R square value. That is your model you have to select. Are you clear with this? Just type yes in the chat box. Super clear. So linear models we have already studied in our green belt level. Okay. Today we have studied the quadratic as well as cubic. ये इक्वेशन लिख के ले लो. ओके इक्वेशन लिख ले लो. ये दोनों भी इक्वेशन, तीनों इक्वेशन, लीनियर, क्यूबिक, quadratic and cubic. Linear we have already studied in green belt. Y is equal to a plus bx, where y is the output, x is input, a is the intercept, and b is the slope. Right? That's what we have studied. Yeah. We have run all the three and take the values for all. Yes, exactly. So मैं आपको दिखाता हूं. Meanwhile, open the next file. एक बार इसको करेंगे multiple regression. So let me show you that. Let me show you that quickly. All the three modules here. Okay, first the simple scatter plot, then the linear model, then the quadratic model and the cubic model. Okay, all the four models in front of you. Clear hai? Just give me yes in the chat box. Yes, how do we go to this layout? Good question. How do we go about this? Once we have the graphs, okay, go to graph. Graph में यहाँ पे click कीजिए. Just a second. Huh? एक बार ग्राफ पे एक बार यहां पे क्लिक करिए तो एक ग्राफ ओपन होना चाहिए, एटलीस्ट वन ग्राफ. ओके, देन व्हाट यू डू, ओपन एनी ग्राफ, गो टू एडिटर. एडिटर में आपको ये लेआउट टूल मिलेगा. कैन यू जस्ट गो टू एडिटर, गो टू लेआउट टूल. हाँ, देयर इज अ मार्जिनल डिफरेंस बिटवीन आर स्क्वायर. यस एग्जैक्टली. एडिटर में लेआउट टूल यूज करो. In that, whatever graphs you have prepared, all the graphs will come on the list, left hand side. No, not stamping matrix. वो matrix plot अभी मैं दिखाऊंगा. This is not matrix plot. ये अलग है. ये this is actually a kind of dashboard, a quick layout. Okay. So after that, you can just select whichever graph you want on the left hand side. Okay. Double click on that. It will get selected automatically like this. And you can increase the number of graphs as well. So editor में layout tool नाम का एक option है. Editor layout tool. Okay, then you can play around this. ठीक है जी. चलो, have you opened the last file which I have given to you? Have you opened the last file? The final frontier. Last बोलने के बाद, okay, that's the last one. Thank God. Thank God. Today was too horrible, isn't it? See, if you want to become the black belt certified person, then you have to know at least this much. All right? हाँ, थोड़ा सा. So now coming back to this, here in this sheet we have one y, which is our defect fraction, and multiple x, x1, x2, x3 and x4. Okay, so we have defect fraction in the column 1, and then 1, 2, 3, 4 are our x's. So here y is equal to function of x1, x2, x3 and x4. Okay, so x1 is tool aging, x2 is temperature, x3 is speed, x4 is experience. So we can go one by one, or we can go matrix plot. What is matrix plot? Go to graph. The second option is matrix plot. Just observe here. Itna मैं दिखाता हूं, then and I will show you how to make the equation, and then I will close the session. Okay. graph matrix plot. Everybody follow this graph matrix plot. Now, what I'm showing you is how do we create a plot of multiple x's with one y in one shot. Okay. So go to graph. Second option is matrix plot. Select by default simple. Now here, observe here. How do you have to select the options here? You have to select like this: x1, x2, x3, x4, and then y. This is the equation. This is a sequence in which you have to select. First x1, then x2, then x3, then x4, and then y. Okay, everybody? चलो select करते हैं फिर. Click on graph variable. First is x1 is tool aging. Double click on that. Temperature. Double click on that. Speed, double click on that. Experience, double click on that. And finally, you have to select the y, which is the defect fraction. Everybody with me? Just give me yes in the chat box. Just give me yes if you are with me. Now, don't yet click OK. Just go to matrix option. Just go to matrix option. And in the matrix display, select lower left. Go to matrix option and select lower left here. And just click on OK. And click on OK. And you will get something like this. Everybody got this? Just give me yes in the chat box. Very good. Now, which four graphs you have to see? The four graphs at the bottom. Look at this here. Graph number 1, graph number 2, graph number 3, and graph number 4. So graph number 1 is nothing but tool aging and defect fraction ka graph. Okay. So this is the graph between age of the tool and how much defect you are creating. Okay. Now tell me, is it a positive correlation? Is it a positive correlation? Yes, it is positive correlation because the x is increasing, y is increasing. See, positive correlation looks like this. Okay. In this as well, there are two types. There is a moderate positive. For example, let's say there is a spreaded data. In this case, the data is a little spreaded. Is it positive? But it is moderate positive. Iska R square value will be around 60%. There is something called strong positive correlation where you will have the data which is very closely bound with the line of best fit, where R square value will be 97%. Are you clear with this? Both are positive correlation. One is moderate positive, second is strong positive. Are you clear with this? Just give me yes in the chat box. If you observe data, the graph number 2nd and 3rd, you will find this kind of very strong positive correlation. Are you observing this? Temperature and the defect fraction, and the speed and the defect fraction. Are you clear? Strong positive correlation. Just give me yes in the chat box. Where R square value will be more than 97, 98%. Okay. And coming back to the fourth equation, fourth graph. Experience and the defect fraction. What is the relationship? Is it positive? Is it negative? Is it no correlation? Type in the chat box. Is it positive? Is it negative? Is it no correlation? Everybody, give me your answer in the chat. Exactly, it is no correlation. Because whatever is happening with X, there is no impact on Y. So there is no connection between X and Y. Okay. And this is called a matrix plot. Now, can we get y is equal to a plus bx equation in this matrix plot? The answer is yes. How do we get this equation? Go to stat, go to regression, fit regression model. Just follow this path, please. ये करते हैं, बाद में we'll close the session. Okay. Stat, regression, fit regression model. Just click on that. Stat, regression, fit regression model. Okay. Here in the response, that is our y, which is our output. What is that? Which is defect fraction. Double click on that. And continuous predictor, which is our axis. Just select tool aging, temperature, speed, and experience. Double click on all the predictors, which is our axis. So response is our Y and predictors are our axis. And click on OK. And that's it. You can have this regression equation over here, which is defect fraction equals minus 0.01355 plus 0.000018 tool aging plus 0.000108 temperature, etc., etc., etc. This is called the regression equation. Have you got it? Just type yes in the chat box. सबको मिला है? Just give me yes. Selection order can be anything, Preeti, here. Only responses may you have to select the Y, which is our defect fraction. In excess, order can be anything. Order need not to be in sequence. Okay? Yeah. Got it? Just give me yes in the chat box. So you can find a graph and you can find this equation as well. This is the multiple equation. Y with multiple x's. Are you understanding? Y with multiple x's in one equation. Clear? Super. Amazing. So what we'll do is, today we will stop here. And tomorrow we will continue this, where all whatever we have studied, it will be amalgamation of that in design of experiment. So tomorrow it's going to be very exciting stuff, where it will be summary of hypothesis testing, regression, statistics, control chart, normal distribution, okay, modeling. Everything will be covered under one topic called design of experimentation, and you will love this. Okay, so we'll stop here. Tomorrow we'll connect again at 7 p.m. and that will be the last day of our hackathon, and that will be a phenomenal experience. That's my guarantee. Okay, so till the time, keep learning, keep growing. Okay, the recording will be available in the, not in the masterclass archive, but in the hackathon, black belt hackathon. Okay, yes, got it. Valuable session. Thank you very much. Thank you very much. Okay, see you tomorrow at 7 p.m. sharp. Okay, take rest and good night. Bye bye. Take care.